Hi guys, welcome back to Math with OG. In this video, we'll be talking about Venn diagram. What are Venn diagrams? These are diagrammatical representation of sets. So when you present sets using diagrams, we call it Venn diagram. Now when you have an operation concerning more than one set, both sets or three sets can either be overlapping or disjoint. Disjoint set are set that has nothing in common. For example, you have this, it has nothing in common, while overlapping sets are sets that have something in common. For example, all the other type of Venn diagrams you have here, they are overlapping sets. So on the board, as you can see, we have different diagrammatical representation. So I will explain them one by one and what these various Venn diagrams mean. Now, starting with this guy here, this is simply two sets that are overlapping. That means there's something in common. So there are some members that are present in A and B, and you can find them here. Here you have those present in A only and B only. However, we don't have a universal set guiding this particular guy. Over here, we have a universal set guiding these two guys, but these two guys, they are disjoint sets. It means there's nothing common to A and B. So example of this, you can see a set of men and a set of women. You can't be a man and a woman. But in this case, you can see a set of people studying biology and a set of people studying economics. You can see some people studying both biology and economics, and you'll find them here. That means in high school, doing both biology and economics, you'll find them here. So this guy here is similar to what we have here, just that in this case, we have a universal set. So because of the presence of universal set, you can have some elements that are neither in A or B, but they are universal sets. You can find them around here, roaming about, not in A, not in B, but in the universal set. Now you can also have those common to A and B, those for B only, and those for A only. Now what we have here is a three subset Venn diagram. You should note that at this level, we study or we teach to three subset Venn diagram. We don't see this, but you can also have a four subset. You can also have five subset as the case may be. Though as the number of subsets is increasing, the diagram is becoming more complex. Now what I have here is A only, B only, C only. What I have here is A and B. What I have here is B and C. What I have here is A and C. Now what I have here is A and B only. What I have here is A and C only. What I have here is B and C only. What I have here is what is common to A, B, and C. We'll throw more light on this when we start answering questions concerning three subset Venn diagram. Here we also have a universal set. We have a subset A and we have a subset B, where every member of subset B is also in subset A, where every member in subset B is also in subset A. You can have a universal set to be a set of secondary school. Then you have subset A to be a set of SS3 students, while subset B is a set of science students in SS3. You can see everybody in subset B will be in subset A, and everybody in subset B and subset A will also be in the universal set. Now we can have this guy here, three sets overlapping. However, you have only two overlapping, the three are not overlapping. That means there's nothing common to A and C, but there's something common to B and C, and there's something common to A and B. So you can have an example: married men, married women, single men, and single women. So this B can be for married people, C will be for women, and A will be for men. So since B is for married people, in between B and C, what you have here is married women. In between A and B, what you have here is married men. So what will be here is single women. What will be here is single men. So as you can see, there's nothing common to single men and single women. So you cannot make C and A to overlap. You can't be a single man and also be a single woman. It's not possible. There's nothing common to men and women. So that's an example you can see here. That's overlapping, two just overlapping, not the three overlapping. Now this guy here is similar to this, just as in this case there is no universal set. So this is just what Venn diagrams is all about. Now we'll start applying it in different operations. You understand better what or how you use your Venn diagram. In our next video, before entering operations proper, complement of a set can be called an operation, but it's not one of the main operations like intersection and union. In our next video, we'll be looking at the complement of a set. We'll be talking about the meaning of complement of a set using diagrammatical representation and also using your rule method representation. Thanks for watching this video. If you like it, use the like button. Don't hesitate to subscribe if you've not done so already, and use the share button to share to others. Then also, if you think there's any error in what we did, leave that in the comment section. And if you have any question, also leave that in the comment section. Thanks for watching once more, and see you guys in my next video.